This is pre-calc video on 6.2 applications. This is part 2, a new problem. All right, a diagonal path through a rectangular park is 600 feet long. One side of the park measures 350 feet. All right, so sometimes, you're not given a picture and you've got to be able to draw a picture based on the wording. All right, so that's what I'm going to do. It says it's a diagonal path through a rectangular park. So I'm just going to draw a rectangle. Okay, so the rectangle has 4 right angles, opposite sides are congruent. Gotta remember all that stuff in geometry. And the diagonal path, there it is. The diagonal path is going to create 2 congruent right triangles. Okay. And that diagonal path is 600. One side of the park measures 350. Right? I don't know if it's the short end or if it's the long end, but I'm just going to pick one and label it because the math is going to be the same regardless. The only one that's really important to have labeled in the correct place on the picture is the hypotenuse. All right, how long is the other side of the park? Okay, so I want to know this one. All right. So this is a Pythagorean theorem problem. I'm given 2 sides of a right triangle, so we're just going to use a squared plus b squared equals c squared. So I've got 350 squared plus x squared equals 600 squared. Okay. So x squared equals the square root of 600 squared minus 350 squared. Okay. Oops. Hold on. Let me undo this. I'm doing too many steps at one time. All right, so I'm trying to get x squared by itself. Now I want to take the square root of both sides. So I've got x equals the square root of 600 squared minus 350 squared. And from that point, I just plug that into the calculator. No. Okay. All right, so the square root of 600 squared minus 350 squared. 487. Let's see what it's telling me. How long is the other side of the park? All right. I'm just going to keep the same amount of significant digits. I mean, they gave us to the ones place. So I'm going to give back to the ones place. So I've got 487 feet. Okay. What angle, this is part B, what angle does the diagonal path make with the side whose length you found in part A? All right. So here's the length I found in part A. And here is the diagonal path. And so therefore the angle is this angle here. Okay. All right, so I've got I always want to try and stick with the part that's given. Okay, so let's try and get, I've got 600 that was given. 350 that was given, all right? 600 is already in the triangle that I've highlighted. 350 is not, however, opposite sides of a rectangle are congruent. So therefore, the other side here is also 350. Okay. So I've got opposite was given and hypotenuse was given. So therefore the sine, call this angle theta right here, the sine of theta equals 350 over, whoa, what the heck is that? 350 over 600. So I'm going to do the inverse sine. 350 over 600 equals theta. Make sure I'm in degree mode. Always check that. It's so forget. Alright, so I'm doing second sine 850 divided by 600. Alright, so rounded to the nearest degree, that would be 36 degrees. Next. Alright. The angle of elevation from a point on the street to the top of a building is 53 degrees. Alright, here's something you need to know. I think this is the first problem where we're discussing angle of elevation. Let me get a blank page here. Angle of elevation. Hold on, I can't spell. Elevation. Angle of inclination. Angle of depression. I'm trying to think, is there any other words we can use? Those are ones that are coming to mind right now. When they talk about these things in a word problem, they're always measured with the horizontal. Always measured with the horizontal. Always measured with the horizontal. Right? Going back to this problem. The angle of elevation from a point on the street to the top of a building is 53 degrees. So let's take this point on the street, okay? And I'm measuring an angle of elevation to the top of the building, okay? That is being measured from the horizontal. Now, the horizontal is on the ground. The ground is perpendicular to the building. All right, so here is my right triangle right there. And this angle right here is 53 degrees. Okay. Oh, I still can't make a 53. That's 53 degrees. All right, the building is 60 feet high. All right. How far is the point on the building? How far is the point on the street to the foot of the building? So this point over here, this is where the angle is being measured from. We're talking about the measurement from that point to the building. There's my x. Okay, so we're trying to relate the angle that was given with the side that is known and the side that is unknown. So the side that is known is the opposite, and the side that is unknown is the adjacent. So opposite over adjacent is tangent. The tangent of 53 degrees equals 60 over x, right? Multiply both sides by x. Get x to cancel, okay? So now I've got x times the tangent of 53 degrees equals 60, and now I am going to divide both sides by tangent 53. So x equals 60 divided by the tangent of 53. Calculator, 60 divided by tangent 53. So x equals 45. All right, let's talk about our units here. This was measured in feet. I love feet. My answer is in feet. Also, let's check about the rounding. How far is the foot on the street to the foot of the building? It doesn't really talk about what units I should use or how I should round, so I'm just rounding to the nearest foot. All right, there it is. All right, that was a 10-minute long video, so that's enough of that. I'm going to make part 3 for more examples.